Okay, welcome to the last bit of our pre-calc course for this distance learning. What we're going to do today is fill in this table for sine, and then the table down below is for cosine. You should be able to also see this attached notes paper on Google Docs. I am going to start with filling in the degrees on the left here because the radians are what's given. So I'm going to start with 0 degrees. Pi over 6 is 30 degrees. Pi over 4 is 45 degrees. And again, have your unit circle out so you can follow along. All we're doing is just pairing up the degrees with the radians. Pi over 3 is 60 degrees. Pi over 2 is 90 degrees. 2 pi over 3 is 120 degrees. 3 pi over 4 is 135 degrees. 5 pi over 6 is 150 degrees. Then we're at pi, which is 180 degrees. Then at 7 pi over 6, we're at 210 degrees. Sorry. At 5 pi over 4, we're at 225 degrees. At 4 pi over 3, we're at 240 degrees. Then at 3 pi over 2, which is all the way at the bottom there on the y-axis, we're at 270 degrees. And then at 5 pi over 3, it's 300. 7 pi over 4, it's 315. That's your 45-degree angle in the fourth quadrant. Then 11 pi over 6 is 330. Oops, I think I messed up a little bit with that. Sorry, 330. And then we're at 360, which is at 2 pi. And I guess my chart just got moved a little bit. Okay, now we are going to write the coordinate next to each degree in radian and degree mode. Sorry, each angle. So where it says exact at the top of your paper and approximate, okay? We're going to just go over kind of the exact portion, and then I'll fill in the approximate so you can see it. So when we're at 0 degrees, what's the sine? Remember, sine is the y-coordinate of the unit circle. So we're looking for that y value, which happens to be 0, okay? So I'm going to put in here 0. Okay. Pi over 6, again, what's the y value? It's 1/2. Okay. Pi over 4, that's our 45-degree angle. It's square root 2 over 2. Pi over 3, the y value is square root 3 over 2. Then at pi over 2, we're at 1. Now in the second quadrant, remember all your y values are positive. So in the second quadrant, 2 pi over 3 is also positive square root 3 over 2. Then 3 pi over 4 is square root 2 over 2. That should be a 2 there. And then 5 pi over 6, we're at 1/2. And at pi, we're back to 0. And look at how the values kind of went up to 1, and now they're coming back down to 0. That's what you're going to see about the sine, is that they're nice patterns. Now in the third quadrant, the y-coordinate is negative. So 7 pi over 6, we're negative 1/2. Okay? At 5 pi over 4, we're at negative square root 2 over 2. At 4 pi over 3, we're at negative square root 3 over 2. At 3 pi over 2, we're at negative 1. At 5 pi over 3, we're at negative square root 3 over 2. Okay? And we're now in the fourth quadrant here, so we're going to still be negative. So this is your 45-degree angle in the fourth quadrant, negative square root 2 over 2. And then negative 1/2 and 0. The reason why they have the approximate column is because we don't know really what square root of 2 over 2 and square root of 3 over 2 is. So I'm going to fill out the approximate column, and then you can see what these decimals are. And then we're going to graph this. Okay, as you can see on the column on the right of this table, I have put in the approximate. If you look, it goes like 0, 0.5, then 0.71, 0.87, then up to 1. Then notice how those values are repeated coming back down to 0. Then they go all the way negative to -1, and they come back up to 0. So what we're going to do is we're going to go over here to the right, and we're going to graph all of these values. As you see these little grid marks right here, these all represent your different angles. In trigonometry, majority of the time, our values are written in radian, not in degree. So this one that's way out here by itself, that's pi, so that's your halfway mark. So I'm going to label that, and I want you to do the same, okay? Okay, so now I'm looking at my graph portion, and I've got my values over there on the left of my sheet of paper, okay? So every other space you can see is like your 90, your 180, your 270, and 360. So the first one I'm going to mark is 0, which is at that origin. And then way out to the farthest away from it, I'm going to mark 2 pi, because we're writing this in radians, okay? And then the halfway mark between those two is going to be pi. I'm going to put pi in the middle. So what I'm going to do is I'm looking at that halfway mark between 0 and pi, the one that's kind of by itself, and that's at 90 degrees, so it's pi over 2. Okay? And now I'm going to kind of do that halfway mark between pi and 2 pi. So remember, this is 1 pi, this is 2 pi. What's halfway between 1 and 2? 3, 1.5. So we're going to call that 3 pi over 2. Now, these are going to always be your 5 main points that you're going to always plot. Okay? I'm going to fill in the other points so you can see that. Okay, now it's all filled in. Over on the right, I had to write a little bigger than where the points are, but this last mark is really 2 pi right there. Okay? Now, why do we only have 1 and -1 as our maximum values? Well, remember, this is the unit circle. So the highest we will ever get to, remember, was 1, because that's the farthest away we are from the origin. That's why the radius of the circle is 1. Okay, so now it's time to graph this just to see what this looks like. So we start at 0. 0 is our first point. Okay. And then think about where pi over 2 is. We know that it's at 1. So I know like in between, halfway of that was that kind of 1/2 value. And remember, who was 1/2? That was at 30 degrees, was at 1/2, and that's this mark right here. Okay? Then pi over 4 was approximately like 0.7, so a little bit higher. Then pi over 3, it's like 0.8 reaching there. Okay, and then remember, we're going to come back down. So at 2 pi over 3 is the same value, 0.8. Then at 3 pi over 4, we're at 0.7. Then 5 pi over 6, we're back at 1/2. And then at pi, we're at 0. So it looks like a parabola right now, upside down. But then you remember, we're going to be negative in the third and fourth quadrant for sine. So at 7 pi over 6, we jump right to 0.5. Then we're at -0.7. Then we're at -0.8. And then at 3 pi over 2, which is at 270 degree, we are right there at -1. Then we continue, and we've got -0.8, -0.7, -0.5, and then right here, which this should be 2 pi, even though I ran out of space with my writing, we're back at 0. And this is the sine wave. That's what it's called. So I always have all those sine jokes for you. Now, there's some vocabulary we need to talk about. The first one is called your baseline. Can you think about which would be the baseline? Well, if you thought it was the x-axis, congratulations. You are correct that the x-axis right here is called your baseline. Okay? So, I'm going to write baseline. Okay? Well, these are waves. So if you've ever been to water and seen waves, waves always have a height. Well, the height of this wave, and draw this in green, is from the baseline to what we call is the crest, or the baseline to what we call is the trough. Crest is your highest, trough is your lowest. Okay? Well, the word for that is called amplitude. So amplitude, if you listen to music a lot, amplitude is your kind of how you make that height increase and decrease. So the amplitude is 1. And remember, it's from baseline, and we're going to label the top here called the crest, and the bottom called the trough. So baseline to crest or trough. Okay? And remember, this is called the y equals sine theta graph. Remember, sine is always equal to the y coordinate of the unit circle. Now, another couple things is the domain and the range. Okay? Well, the domain is what's the farthest left to the farthest right this graph goes. Well, the farthest right for this domain is from 0. And right here, hold on, this particular domain starts at 0 and goes to 2 pi on our graph. But the domain of this wave actually goes on forever and ever and ever. So the domain we call is from negative infinity to infinity right here. Okay? Now the range is the easy one. What's the lowest this graph goes to the highest this graph goes to? Well, the lowest is -1 and the highest is +1. Okay? Now, remember, going one whole time around the unit circle is going from 0 to 2 pi. Well, we call that a period. So, starting at 0 and going to 2 pi is considered one period. And so they call that period 2 pi, or 360 degrees, if you're in 360 degrees. Okay, that's it for the sine graph. The next video is going to be about the cosine graph.